Good evening, respected speakers, Director of BCIIT, faculty members, and dear participants. I, Ms. Mansi Vats, Assistant Professor of Banarsidas Chandiwala Institute of Information Technology, extend a warm welcome to all of you on the fourth day of our faculty development program on the role of generative AI and its applications in today's era. Over the past 3 days, we have had the privilege of delving deep into the fascinating world of generative AI, understanding its mechanisms, exploring its diverse applications, and reflecting on its transformative impact across various industries. Today, we continue this exploration and focus on how these advancements are shaping our future and redefining the way we work, learn, and innovate. Now, I am very excited to introduce our esteemed speaker for today, Dr. Ratan K. Datta. It is an absolute honor and privilege to welcome Dr. Ratan K. Datta, a distinguished academician, scientist, and visionary leader, as the resource person for today's faculty development program. Dr. Datta, with his PhD in monsoon dynamics and atmospheric modeling from IIT Delhi and extensive training in modeling and computing across India, USA, and Japan, has made remarkable contributions to science and education. His illustrious career spans over decades of pioneering research, during which he has authored 100 plus research papers in reputed journals, written books, and delivered expert lectures globally, including prestigious platforms such as Vatican Academy, Florida State University, and European Center for Medium Range Weather Forecasting, UK. A trailblazer in the field of meteorological and computational sciences, Dr. Datta played a pivotal role in the establishment of the National Center for Medium Range Weather Forecasting, where he introduced India's first supercomputer for monsoon modeling. His leadership as the UNDP expert in East Africa, chief scientist for the International Monsoon Experiment, and numerous other roles have made indelible marks in the scientific community. In addition to his research contributions, Dr. Datta has demonstrated exceptional commitment to education as an adjunct professor at leading institutions and a mentor to numerous postgraduate and doctoral students. His dynamic leadership extends to professional bodies, having served as president of the Computer Society of India, Indian Meteorological Society, and Gwalior Academy of Mathematical Sciences. Among his many accolades, Dr. Datta is the recipient of the Lifetime Achievement Award by CSI, Bharat Jyoti Award, and Golden Jubilee Award, to name a few. His outstanding contributions have been recognized globally, establishing him as one of the leading scientists of the world. We are truly fortunate to have such a luminary with us today. Dr. Datta's expertise and insights will undoubtedly inspire and empower us to elevate our academic and professional pursuits. Please join me in extending a warm and enthusiastic welcome to Dr. Ratan K. Datta. Now, it is my pleasure to invite Dr. Ratan K. Datta to start the session. Thank you. Over to you, sir.
Thank you very much, Madam, for my introduction. I would like to say that IMD celebrated 150th year of its starting in 1875 at Calcutta. That's where the IMD started. Then it went to Shimla, and from Shimla it went to Delhi, and that's how we are started 150 years earlier, doing a lot of services. I'll go to the next. The basic thing is, let me first say something. You have spoken about the medium range weather forecasting. So that's where I had played a role in getting from 1964 to a IBM 1620, learning Fortran 2, and then going to IBM 36044, learning Photon 4 and teaching people Photon 4. Because when I did my MSc physics, we didn't have computer science. So then in 1989, we got the first supercomputer next. That is the 150 years of excellence. As I said, 1875, we started this IMD. And I have been responsible for working on numerical weather prediction and using computer from as early as 1970. Next. So this is the supercomputer which I got in 1988 and was inaugurated by Mr. Rajiv Gandhi, then the Prime Minister of India, at IMD at the first floor of the satellite center. And now this supercomputer is lying as a sample at 62 sector Noida, where I purchased 35 acres of land for office as well as the residential area. Now they have much bigger supercomputers, and that's the only one available in the country. When I got this supercomputer, it was the only one in the country. No other person had this supercomputer. This was the Cray XMP. Now we have, because Samuel Cray was the person who started this and all that. So this is type of thing. So that is type of thing which we did. Next. So now talking about the weather forecasting. Weather
Hello, sir.
forecasting is
Dutta
having
sir.
talked
Sorry for
right from
interrupting, sir, but your presentation is not visible, sir.
presentation is not visible.
Could you please share your screen, particularly that window where you are running your presentation, sir?
Just a moment.
No issue, sir.
Now you are able to see it.
Yes, sir. Now your screen is visible, but presentation is still not there, sir.
Presentation is not there.
No, sir, but your screen is sharing now, sir. But now you have to open that presentation window, sir.
Are you able to see the introduction to weather forecasting?
No, sir, not presentation.
करिए, ठीक करिए.
हाँ जी अभी देखिए अभी दिख रहा है ना अभी दिख रहा है ना ठीक है मैं अभी करता हूँ ठीक है
Yes, sir. Now it's visible, sir. Thank you.
Okay. All right. So as I started saying that 1875, IMD started in Calcutta and then shifted to Simla. So we started calling Simla office and all that, and then shifted to Lodi Road. So Lodi Road is the main campus now where the IMD function. Of course, there are IMD Pune, IMD Bombay, all the places are there, but basic headquarter is at New Delhi. I was responsible for setting up numerical weather prediction group in as early as 1970, in June 1970. So that type of thing, which we started working on numerical weather prediction. Next. So this is the supercomputer which I got. Are you able to see this? Are you able to see the picture?
Yes, sir, it's visible now.
Okay, fine. So therefore, you could see I am standing there along with Mr. Rajiv Gandhi and taking him round. And this, the the colored system is the supercomputer, which you can see here, the tall supercomputer, and those bench, which look like bench, also have a lot of circuitries in there. So whole thing is circuitry, and that's the type of supercomputer which we had and all that. Next. So now we go to the introduction to weather forecasting. Weather forecasting is the process of predicting atmospheric conditions of specific period using scientific data and models. So it involves current weather, the historical pattern, complex meteorological data. What is the meteorological data? So we are having so much things available. That is, we started with pressure, with winds, with that, all that. And then we start with rainfall, with the clouds and all the type of things. We have to predict all the things, wind speed, precipitation, all type of things we have to predict. So then comes the most important things are disaster preparedness. Cyclone happens, hurricane happens. What happens? A lot of people can die. So therefore, you have to evacuate them from the coastal area where very high floods come up. There again, you have to evacuate people. Agriculture planning, you have to do the planning of agriculture and you have to do research along with the agriculture people. So you have agrometeorology. So transport and logistic, that means now aviation, aircraft have to take the forecast from the weather office. So that every airport has a weather office. So that gives the forecast for the weather. So similarly, energy sector, the water, all type of thing, public health and safety, where the rainfall occurs, where the mosquitoes come up, where the things happen, all the things. Now, in armed forces, defense production, defense people have the people who are using the uh, the forecast of weather, because there are proper air force weather people and army weather people, so and navy weather people. All the three disciplines have weather people amongst them, so that you are air force has a much bigger, the air commodore is in charge of this, or air vice marshal is in charge of the weather forecasting. Whereas in Navy, there is a group captain or higher person is in charge of this. That type of thing is happening. Next. So basically what we used is weather forecasting based on observations. How do you take the observation? We have all type of stations all over the country as all over the world, because for forecasting weather over India, you don't need only weather observations over India. You need around the world. So that's where we are now using world forecast, total world forecast, both in the surface as well as top. So we take observations as high as from the satellite picture and as low as on the surface. Earlier, we didn't have much information from the sea surface except from the ship reports. Now we get a lot of information from the satellite picture. Cyclones, we get pictures from the cyclone. When you see the cloud formation and the cyclone happening, you start playing with the mathematical techniques and information from the satellite as well as weather chart, that what is happening. So that's the type of thing which we are different forecasting methods use. Next. So these are the various challenges, because the weather is of a very dynamic nature. So many changes are happening in the weather. You get clouds, and cloudburst can give very heavy rainfall in one part of Delhi, rest of the Delhi may be without rain. That type of thing, how do you predict? That's where again AI comes up. That's what we'll talk about it. Again, something happens suddenly, so what do? You should be able to warn the people. So that type of thing, sudden things which are happening, that has to be predicted well in time so that people are warned. Tornado, it's a very small scale tornado. Water spouts, very small scale, but you have to warn the people in time so that people are able to saved in this. So that is type of thing. And then because I analyze Delhi rainfall, because Delhi rainfall is a very different picture. Some area rainfall is much less, some area is much higher. That type of thing which is happening. So that type of thing, again, forecast, southern temperature or fog may have good visibility, whereas Palam may have zero visibility. So, but you have to forecast what visibility should be there for the aircraft and all that. You see now, fog is there. Yesterday, there was zero visibility all over Delhi. That type of thing, you have to warn. No aircraft should land on this day and all that till the visibility improves. Next. So now for satellite data has become, because from 60s onward we have progressed from Sputnik 1957 Sputnik, which Russia started, and state build up lot of things, and we ISRO is now building up excellent satellite pictures. So we are getting huge amount of data, and we are doing analysis, correcting, and all type of things. This is a critical role prepared by improving the accuracy and reliability of weather prediction. And because we are able to see what is happening over the oceanic surfaces. Earlier, we were not able to see what is happening over the oceanic surfaces. We were not able to see what is happening over Himalaya. We give the forecast for the people who go to the Mount Everest. But earlier, we were giving only more synoptic type of picture. Now we are giving more dynamic picture, more accurate picture. Earlier we were giving forecast for 1, 2 days. Now we are giving forecast for 10 days. So 10 days forecast is as good as earlier 3 days forecast. So that type of things has improved. That is the thing with supercomputers and with the good analysis and good data, lot of things have happened. And I find now, for example, a new supercomputer has been purchased by the NCR model. That's the only one available in the country, which is a very high power system, which is being utilized for producing the forecast. Next. So these are the satellite data, visible infrared imagery, water vapor data, microwave radiometer data, atmospheric profile, vertical profiles, temperature, humidity, and pressure, sea surface temperature. You get it because that important. If sea surface temperature is warmer, that's the time cyclones can form and all that. Those are the things which are very, very important. Ozone, which is very helpful for the radiation, for the purpose of human health, for all the type of thing, we also study this, that type of thing which satellite data provides us with the information. Next. Role of satellite in data assimilation. Now, data assimilation, because after all, you need initial fields for any prediction, any forecast, you need initial field, and then you predict for 1 day, 2 days, 3 days, 4 days, 5 days, 10 days. And up to 3 days is known as short range forecast. 10 days is known as medium range weather forecast, and more than 10 days is known long range forecast. So we give 10 days forecast and for advisory for 1 month and so on. And then we give monsoon forecast, which is for all the 4 months, but give monthly, again, keep on changing because it's a variable thing in there. Next. So key satellites now system for NLP, geostationary satellite, polar orbiting satellite, specialized satellite, all these are being used by IMD and for the purpose of simulating data. Next. Now, how to NLP, which is, I said I started in 70s, 1969, with using our computers and all these things. But we had no computer. Then we are going to the planning mission. We were going to IIT. We were going to Delhi University and all that. Till we got in 73 our IBM 360 when we started working on our own computers. But before that, I made a case with Delhi University that because I had that I'll send some people. So I put 2, 3 persons who were doing the duty there, and we had an arrangement so that we could have the data received there, forecast produced there, forecast sent back, and then predicted and all. That type of thing which was doing for about 1 year. Later we got our own system, and then we started our own models and all that. And that IBM 360 remained with us for quite number of years. Later we changed over to this. Now let us say what is the NLGP. NLGP next. NLGP parameterization we'll do later. Let us do NLGP later. Go to the next. Okay, these are the 7 equations which are used. Conservation of mass, conservation of momentum, conservation of energy, state equation, that is the ideal gas equation, equation of motion, horizontal and vertical motion, radiated transfer, cloud physics. After this, because cloud is of a small scale, then the general waves and all that. Small scale features, you want to parameterize it. And that is what previous previous. That is where each important physical process that cannot be directly predicted requires a parameterization scheme based on reasonable physics or statistical representation. The graphic depicts some of the physical processes and parameters. For example, the cloud you can see, then you can see the all the income and solar radiation, absorption, all the things are there. Those are the things which are parameterized so that the things are properly used in the equation. Next. So next. So this is the conservation of mass. First equation dp by dp does all this, and then air density, this and all that. So this is the mass in fluid, air in gas over time, because you want to see how the change is happening in the atmosphere. Then the other is conservation of momentum, Navier-Stokes equation. So this is the equation which is Navier-Stokes equation, where this is there. Then you have conservation of energy, d theta by dt, b d theta, temperature, q is there. Q is the heating or cooling, and this is potential temperature, and so on. I don't want you to uh, look at this, but you can see this equation. P is equal to rho RT. So that's again the state equation, ideal gas law, you know, and this is the equation of motion. du by dt, dv by dt, dn. So these are the three different equations. Vertical motion involves buoyancy and gravity account for vertical displacement and horizontal motion, a UV component. These three components are taken, and F is the correlative parameter, which are there. These are the Navier-Stokes equations. And then this is the radiative transfer, di by dt, all these things there. Then let's not go into detail. This is the cloud physics and precipitation equation, dn by dt, where n is the cloud, water, or ice content, and S is the source term for cloud process and all that, which is parameterized and taken very carefully. So different methods of parameterizations are done. So those lot of research is done on the parameterization, and these are done on this. So you can say there are still problem. Space observation network is not complete. Its historical data is not very reliable, because somebody is measuring in inches, somebody is measuring in centimeters, somebody is measuring in feet, somebody is measuring, all these type of things are there. So these all data is collected, and error correction take place. 79, we had that monsoon experiment where all the data, most of the work was done in correction of the data and then using it for this research purposes. So that research created lot of things and showed that dynamic model, endology model can produce very well. Because before 1950, 1911, numerical weather prediction was done by Richardson, a scientist from England. But he did the numerical equation by finite differences scheme, but he did not get the good result. But he set up the method which take up 1950, a scientist Charney from US, he produced a good barotropic model which was not baroclinic but showed beautiful results and all that on ENAC computer. And now we are using all the 7 equations. We are using global model. We are using whole earth, vertical and horizontal whole things. And we are taking the whole mountains and oceans into the system. We are playing with all the things. We are taking ocean, atmosphere, interaction. All these things are being done for short, medium, and long range forecast. The things are getting improved as more supercomputers are coming. Quantum computer, we are seeing future. Now, a lot of research is being done on quantum computer, and hopefully, another 10 years, you will see a quantum computer doing forecast for the weather. That type of thing which will happen next. So these are the challenges. Model has limitations because parameterization, small scale system, cyclones and all these things, and very different phenomenon. Computational constraint, because you have a supercomputer, but that is, because for example, 89 supercomputer is practically zero. Your mobile is probably, laptop is faster than that. Now supercomputer which has spent few thousand rupees, crore rupees, that also is a supercomputer, but then after 10 years, you would need still higher supercomputer so that you can do much better forecast for this. So accuracy and speed, because if you have to produce 10-day forecast in 2 hours, that's okay. If 10 days forecast take 2 days, that's not good. So that's where it happens. Earlier, 24 hours were taking for 24-hour forecast, but it produced good method. Now, for example, few hours it takes for 10 days forecast. That's okay. Now you have to come few minutes for producing 10 days forecast, few minutes to producing 1 month's forecast, that type of thing, supercomputer. And then you have to do more analysis, more mathematical parameterization, introducing certain methods by which you could get better forecast. That's where AI is going to play a major role, according to me. Next. So this is how AI helps in weather forecasting. After leaving my NCM or WF, I have 9 students who were computer scientists who did work on AI and produced weather forecast. So all of them are doing extremely well in their life. They are number two, are senior professor, are senior associate professors, and all the one. So they have somebody is in Canada also. So those people are doing excellent work. Those did their PhD from IIT Delhi, PhD from BIT Pilani, PhD from PTU, PhD from Segaria University, PhD from MD University. All these students did excellent work using AI for this. Next. So AI application is weather forecasting. That is machine learning, pattern recognition. AI models, are machine learning. There is a high resolution simulation. AI enables faster and more detailed climate simulation by optimizing computational resources, providing insight into regional climate effect. It does the prediction of climate change. It does lot of things in data assimilation, because initial assimilation of data to produce the current situation of the whole weather over the globe is very important. That's why data assembly is. So Google AI uses machine learning models to refine climate simulation by reducing computational time while maintaining accuracy. Next. So AI application in weather forecasting. So you have short-term forecasting, nowcasting, which is a few hours, 10 hours and all that. Then 3 days forecast. Then medium range forecasting is 10 days forecast. And long-term forecasting is more than 10 days forecast. So accuracy has to improve at all the level forecast. It may be monsoon forecast, it may be daily forecast, it may be cyclone forecast, it may be daily rain forecast. But only if you look up Delhi, Delhi is a place which covers such a big area. At different location, different things might be happening when it is a thunderstorm rainfall. Somewhere hail may be forming, somewhere it may be clear sky. So this is a happen, and that has to be predicted very well. It is very difficult, but I think we are working hard for this so that we are able to predict, because AI is going to be used for this type of thing. Next. So this is the AI system. So you have to generative AI, deep learning, neural network, machine learning, artificial intelligence. So artificial intelligence, there's an expert system. That expert systems are also there. So which rule-based system and all this you have studied and all that. Those are all important systems which are being utilized for weather forecasting. So here the deep learning and neural network and machine learning are the three different methods which are used by my students for their PhD work. And that's the one example I'll show you. They are the method. Expert system can again be used for machine learning. Nowadays, for all the MCA students, I keep on telling them AI has become viral. So you must use AI in your forecast. You must use AI for even e-commerce thing. You must use AI for administrative purpose. You must use AI for everything. So that's where I used AI for weather forecasting also. Next. So key AI technique used in weather forecasting is supervised learning. That is the temperature, humidity are paired with the known output. So that application in weather forecasting is predictive specific weather event like rainfall, storm or heat wave. Cloud burst. The cloud burst is a very important phenomenon where big things happen. Tornado, as I said, it's important thing. So that AI can be used for this purpose. AI doesn't give you the perfect forecast, but AI gives you satisfying forecast. That is, it helps the people to save themselves in their from the disaster. Next. So unsupervised learning involves training the model on unlevel data to find hidden patterns and clusters. So application in weather forecasting, clustering of weather condition for grouping area with similar climate pattern, detecting anomalies such as sudden temperature spikes or unusual weather pattern. Example, K-mean clustering for identifying region with similar rainfall record. So these are the type of things which are used for this. Next. Deep learning. See, convolution neural network is a subtle imagery. It's a very important thing because deep learning models, particularly convolution neural network, are highly effective in processing and analyzing visual data like satellite image. The CNNs are specialized neural network designed to detect patterns in image data such as cloud formation or storm system, cyclone and all these things. Now, for example, in early 60s, we didn't have satellite pictures because we were seeing there was some northerly wind at Bhubaneswar. So on that basis, we said something deep is happening. So I said in my forecast, I was working in Calcutta at that time. I said forecast I gave that it is a deep depression or probably a cyclone is forming. But we did not know. Then only next day we found that a lot of people have died because of heavy cyclone. Because we just felt because we couldn't get any information from the sea. There was no ship around that, no satellite. But today you observe cyclone with satellite and give the numerical prediction, which is very, very accurate. And even you go within 20 kilometer on either side of it where the cyclone hits the land. So that type of thing is changing because earlier you were just depending upon your whims and your creative feeling that this northerly wind is important. But how much important it is, you didn't know it. Now, from the cloud picture, from the satellite pictures, you know what importance is. And you know from numerical model what initial conditions are there and what forecast you should be there, how it is evolving from the simple low pressure, how it comes up into big cyclone, seeing the all the temperature bases and all these things. So that thing has changed the whole structure. So AI helps in that way. Next. So advantage using AI in weather forecasting. So that's pattern recognition, machine learning. So the accuracy of weather prediction by analyzing large and complex data set that traditional methods struggle to process. AI models such as neural network, you know neural network, you have a neural network, you have to have the training network and using network. So that is, you first use the data for training and then use it for the actual forecast. Reduction in error by learning from past forecasts and correcting errors. AI systems continuously improve their performance. Hybrid AI models combine physics-based approach with machine learning, further increasing forecast reliability. Because machine learning is a pattern recognition. So that type of thing which happens, which is more of mathematical, geometrical thing, which happens, that helps in really giving good forecast. And I say not a perfect forecast. AI doesn't give perfect forecast. Let me repeat it here. AI gives satisfying forecast. That's all. Next. Faster data processing because of best computer and good AI scheme, we can do faster data processing and analysis of the initial condition, reduce the time required to analyze weather data and generate forecasts. Real-time forecast, AI algorithm process massive amount of data from satellite, radars, and weather station in real time, delivering real, near instantaneous prediction. Example, Google AI for AI weather nowcasting can predict rainfall within minutes by analyzing radar image. अब radar is covering about few kilometers of the area. Now उसका image से आपको predict करना है कितना rainfall होगा. That can be done for nowcasting for big way. That's where the radar data is. Radar, now India is having most of the area covered by total radars. That's what is being planned in 25, 26. And supercomputer, as I said, few thousand rupees, crore rupees have already been installed, and it's going to start working in few days more. And big data, that is the story of big data started with 2011, but that's earlier we were talking of meteorological data as big data, but today there is a whole thing is big data. Take hours or even days to process large data sets, but AI can handle this efficiently, and even quicker decision making, faster simulation allows meteorologists to issue timely updates for rapidly changing weather conditions. Scalability. At AI system can analyze data from multiple sources simultaneously, such as global climate model, historical data, and real-time observation without slowing down. So different combination can be done by AI that one satisfying result can come up with. Next. So advantage of using AI in weather forecasting, there is early warning system for disaster. AI enhances the ability to detect and predict extreme weather events, providing earlier and more level warning. So that flood warning ho sakta hai, heavy rainfall warning ho sakta hai, even forest fire warning can be there with AI. Disaster preparedness, AI powered models can predict the onset of hurricanes, floods, heat waves, droughts with higher precision and longer lead time. It can also help predicting various diseases, because if the if you, certain area are not well covered by it's covered by mosquitoes, it will have various diseases. Similarly, when it is too cold, it might create more breathing problem for the elder people, and so on, so forth. A lot of things are related to AI, so that health also comes into picture. Minimize losses, early warning reduces casualty and property damage by allowing government and citizens to take preventive measures. That is evacuation, such as evacuation and infrastructure reinforcement. तो आप देखिए उड़ीसा कोस्ट पर उन्होंने बड़े अच्छे स्ट्रक्चर बना दिए हैं so that the people can go, if there is a cyclone, people can go there and stay. There is whole water is available, because when the storm happens, this ocean water comes up, the good water is not available in the coastal area. So there has to be provision for the good water conditions and all that. Good food, some living conditions should be there. Continuous monitoring alerts. AI system monitors weather condition 24 by 7, all continuously, and can automatically send alert when abnormal patterns are detected, ensuring timely farming. So even AI is used in daily reporting, that okay, you do this, you do this, this is because depending upon the weather forecast they can produce. Because AI can strongly help in monitoring and even issuing the warning for local people. That type of thing which was not possible earlier, but AI has made it possible. So that's where AI is becoming too viral to make the thing happening. Next. So data quality and availability. These are the limitations of AI in weather forecasting. AI models rely heavily on high quality and comprehensive data to make accurate prediction. However, issues related to data pose significant problems. Sparse data in remote area, inconsistent data source, data errors and noise, historical data limitation. Although satellite observations have solved a lot of these problems, but even satellite data sometimes it has a lot of errors. That error correction takes time. So that again, lot of work is being done by the satellite meteorologists to remove the errors, so that before the it goes to the data assimilation and data analysis, it removes all the errors. So that's the important thing. That next, next. Lack of transparency. AI models, particularly deep learning, are often viewed as black boxes, making it challenging to understand how they arrive at a specific prediction. There is a black box का मतलब क्या होता है कि it doesn't have the intelligence there. So lack of transparency, trust issue, difficulty in debugging, regulatory and ethical concerns. So that type of thing is there in AI, but you are if you use large amount of data for training purposes and use it for the actual thing, that is again solving a lot of problem. That is there in the expert system or in deep learning or neural network. Next. So future of AI in weather forecasting, integration with IoT, Internet of the Things, and real-time sensors, enhanced data collection, IoT devices including smart weather stations, drones, and wearable sensors, collect granular data on temperature, humidity, air pressure, and wind speed. This real-time data allows AI to generate hyper-localized forecasts for specific area, improving weather prediction for urban planning, agriculture, and housing. That's the important thing, because now drones are being used for taking observations. Okay, because pehle drones were only used for certain funds, but now drones are being used so many things. That is for even helping the agriculturist for the providing the pesticides and all that, throwing water and all these things there. That drones are also used for defense purposes. Drones are also used for taking meteorological observations. So drones have become very popular there. Continuous monitoring alert, IoT, Internet of Things sensors continuously feed real-time data to AI system, enabling early detection of sudden changes like flash floods, storms, or heat waves. Example, river level monitoring, IoT system that send data to AI model for real-time. Agar, so Jamna flood is rising, Ganga is rising, and all these things are there. So that because when from the dam are getting overfilled, then dam release the water, immediately the thing system should be known. So that type of thing, the AI helps a lot on this. Disaster preparedness, AI system use real-time IoT data to predict and monitor the progressive of extreme weather events, facilitating timely warning and better disaster management. So that's again a very important thing, because disaster preparedness is a very important thing, and that's the one happens there. Next, modeling long-term trend, AI-driven climate changes, simulating complex interaction, impact assessment for policy decision, predicting climate risk. So that's the AI model analyze decades of historical and current climate data to identify trends and predict future climate scenarios. For example, predicting changes in monsoon pattern. अब क्लाइमेट चेंज पर काम करते हैं कि क्लाइमेट चेंज में मानसून को कैसे इफेक्ट कर रहा है. Simulating complex interaction, AI can simulate interaction between the various climate factors such as ocean currents, atmospheric conditions, and greenhouse gas levels, providing deeper insight into climate changes, climate dynamics, climate changes, and all that. Impact assessment for policy decision. AI helps policymakers evaluate the impact of climate change mitigation strategy, such as carbon reduction or reforestation on global and regional scale. Now, for example, India forest has earlier were diminishing, now it is increasing. So that's again, it's a help for affecting, decreasing the climate change. We want to have temperature minimum. That's where we said by so and so year we'll be able to do, but we should be able to do much faster than that. Predicting climate risk, it identify areas of high risk of climate related disaster, such as prolonged drought, rising sea level, or intensified heat wave, aiding in proactive planning and resource allocation. These are all very important things which our AI is helping on that. Next. So high resolution forecasting, that is it will, AI will enable high resolution forecast down to specific neighborhood or even states. That's where it's important. It's a still things to be impossible to talk about, say, in the Nehru place, this is going to happen. In Connaught place, this is going to happen. It's a very, very difficult thing, but that's what is the attempt being done using AI to predict that type of thing. So that is again is a very difficult thing, but hopefully we'll succeed one day. Quantum computer integration. So now we should start research I have been talking of quantum computing for quite some time, but now quantum computing is almost going into the market soon. So that's why in another 10 years, we should be using quantum computing and running, enabling AI to handle even larger data set and run highly complex simulation real time. Examples are real time prediction of rapid storm intensification using quantum enhanced AI models, that type of thing. Self-learning system, future AI model will be capable of learning and adapting, continuously improving their predictive capability without human intervention. This will ensure better accuracy in rapidly changing things. For example, now there is a lot of pollution in Delhi. How to solve the problem of pollution? Is it the wording of various crop remnants in Punjab and Haryana helping it? No. Please take care of it. That's what research is required to see how much is the effect of those. Or it's a local thing. That's where one has to work about it. Next. So let us study machine learning in rainfall prediction. Next. So this is there is a ARIMA and SARIMA. ARMA is auto-regressive integrated model, and SARIMA is ARMA is auto-regressive integrated moving average, and SARMA is short things and all that. Then uh, numerical weather prediction, dynamic model, numerical weather prediction, empirical technique, regression analysis. Limitation require extensive domain expertise, limited accuracy in handling nonlinear data, ineffective for long-term prediction. So these are the limitation of these all these numerical prediction, empirical technique, ARIMA, SARIMA, and all that. Next. So machine learning models like Google's GenSet have consistently improved the performance traditionally forecasting method. For instance, General Cast surpassed the European Center for Medium Range Forecast EN system in 97.2% of the valued weather variable, providing an additional 12 hours of advance warning for tropical cyclones. So that's the, again, 12 hours advance important. It's 12 घंटे advance information मिल जाए तो lot of help can happen. People can evacuate, people can leave the place and all that. Improved prediction of extreme event. General Cast demonstrated significant superiority in forecasting extreme weather conditions such as heavy rainfall and cyclone, which are crucial for disaster preparedness. This is our AI research mode which are helping, and they are being used in ECMWF. That's being also being implemented in India. Next. Superior handling of nonlinear data. Long short-term LSMT network excel in identifying nonlinear patterns in rainfall data, outperforming linear model like ARIMA that often struggle with complex states. That's the Springer there. The computational efficiency, general cast generates a 15 days weather forecast in just 8 minutes. That's again, it has become much faster because otherwise it was taking few hours compared to the hours required by traditional method, enabling faster decision making. So robustness across diverse conditions. LSTB, long, short-term memory models have been particularly effective in subtropical basins. Ours is a subtropical basin, that's important. Significant improving the accuracy of rainfall run prediction and capturing monthly stream flow variability better than tradition model. So that's the, again, came up in the 2024. This is very recent research on that. Next. Hard, handle large scale and non-linear data efficiently, captures long-term dependency in time series data, adaptable and improve accuracy with more data. Next. So ARIBA and LSTBs, that's the type of thing which is happening. Linear models suitable for stationary time series require data processing, that's where this, and a type of recurrent neural network designed for sequence prediction effective in the time series problem like rainfall forecasting, nonlinear model capable of learning complex patterns, automatically extract features from the raw data. That's the AI has the dynamics which automatically get the features from the raw data. That's what handling missing data also and all that. Next. So this is the actual rainfall over time in Bihar. So annual rainfall over time in Bihar. This next. So research methodology data set monthly rainfall from Bihar state from 1901 to 2015. Approach used data set was divided into training 80% and testing 20%. Training data was used to train the model. Testing data was used to observe the prediction's accuracy. So this is the full data set. Identify X, Y, and then train X 80% of data and use it for test and then for this and then. So that's where the methodology, because you are using much larger data for taking the various parameter, you are able to calculate that. That parameter you use on test data, that is what is going to help you a lot, because that can give much better forecast than if you're using only small data for test trained and all that. That's the type of methodology which is very, very helpful and all that. Next. So long and short time merit consisting out of ARIMA in terms of accuracy. That's what you have seen. It's the accuracy of ARIMA was very poor, whereas the accuracy of LSTP was much more impressive. Root mean square is much low. Next. So this is the rainfall forecast using LSTM. So that's what a paper was presented. The LSTM was forecast was much better. Next. So, accurate rainfall prediction is essential for Bihar's socio-economic stability. Machine learning technique, particularly LSTM, offer significant improvement over traditional model like ARIMA. Adoption of advanced model can enhance forecast accuracy and aid in better decision making. Next. So that covers up the analysis. The what our I have in the PPT. So that's where now you see the basic thing is I it's a time I have covered up with fast manner. If you have any questions, that type of thing we can again simulate certain things which are this, because again we had a conference in NCR Model Jeff, where we went all the forecasters in the uh, Washington people, England people, all the people were there. There we have seen how AI can be utilized, and that's the emphasis was how AI should be able to utilize. Even any forecast AI can be utilized. That's what came out from the conference. So, any question, any suggestion? मेरी शक्ल दिखा दो. Any question, please? Have you understood the use of AI in weather forecasting? Are you able to work on it? Because 9 students have worked on AI for weather forecasting. They were all computer scientists. Anybody? Weather forecasting is most important. That's why government of India is spending a lot of money on the weather forecasting, and NCM RWF and IMD are planning big way all radar application, satellite application, and also big computer. There is only one supercomputer in India, and that's with NCM RWF. That's all, which is after I got it 1989, 88, it is now three channels above. The third supercomputer has come. That was first, then second came, third came, now fourth has come. And that's the only one here at NCMRWF, National Center for Medium Range Weather Forecasting. Nobody has any question? Oh, somebody has raised the hand. Hello? No. No.
Thank you, sir, for your valuable information and guidelines. Any query from anybody?
Any question or suggestion? Anybody?
Any question? Thank you very much, sir.
All the best, all the best. I enjoyed talking to this, but I would love to have questions so that we can discuss it. But anyway, maybe next time. Thank you. Thank you.
Okay,
Good
sir.
evening, sir. Good evening, sir.
Yes, yes, yes.
Sir, good evening, sir. Ravish Saggar, this side, sir.
Yes, sir. How are you, Ramesh?
Fine, sir. Really, it was very informative session, sir. And thanks a lot for joining us.
Thank you. Thank you. I enjoyed very much.
Yes. Thank you, sir. Thanks a lot.
Okay. All the best, then. All the best. All the best. Leave it.
Thank you so much, sir. That was incredibly insightful and thought-provoking session. We truly appreciate the time and effort you have taken to share your knowledge with us today. It's now my pleasure to introduce our next speaker for today's session, Dr. Ashima Hasti ma'am. Dr. Ashima Hasti is currently serving as an assistant professor in the Department of Computer Science at Mata Sundari College for Women, University of Delhi. She has a teaching experience of 15 plus years. Her areas of interest include object-oriented programming, machine learning, and artificial intelligence. She also heads the placement and internship cell of Mata Sundari College and is a coordinator of Mata Sundari Innovation and Incubation Center. We are extremely fortunate to have Dr. Hasti with us today, and I'm certain her session will provide us with valuable insights into the complexities and opportunities that generative AI brings to both research and industry. Without a further ado, please join me in welcoming Dr. Ashima Hasti. Over to you, ma'am. Thank you. Dr. Ashima, ma'am, are you there?
Good evening, all. I hope the speaker is has not joined yet. We can wait for another 10 minutes. Let's take a break for another 10 minutes. We'll all join back with it after 10 minutes. Due to some technical issue, the speaker would be able to join within 10 minutes. So we would all join back within next 10 minutes after a short break. Thank you so much.
I request all the participants to kindly join as we are starting with the session. I hope everyone is finding today's sessions valuable and stimulating. Moving forward in our discussion on cutting edge innovations, we are thrilled to delve into transformative potential of generative AI in today's era. It's now my pleasure to introduce our next speaker for today's session, Dr. Ashima Hasti. Dr. Ashima Hasti is currently serving as an assistant professor in the Department of Computer Science at Mata Sundari College for Women, University of Delhi. She has a teaching experience of 15 plus years. Her areas of interest include object oriented programming, machine learning, and artificial intelligence. She also heads the placement and internship cell of Mata Sundari College and is a coordinator of Mata Sundari Innovation and Incubation Center. We are extremely fortunate to have Dr. Hasti with us today. I'm certain her session will provide us with valuable insights into the complexities and opportunities that generative AI brings to both research and industry. Without further ado, please join me in welcoming Dr. Ashima Hasti. Thank you. Over to you, ma'am.
Thank you, ma'am. I hope I'm audible.
Yes, ma'am, you're audible.
Yes, ma'am, audible.
Thank you. So my topic is generative AI models for deepfakes. Now here's the outline for my session. I'll be talking a little bit about Gen AI, which I think we already have been talking about for the last few days. Then I'll be focusing on what deepfake is, how deepfakes work, how to detect the deepfake, and the various generative AI models for deepfakes. Gen AI, as we have already seen in the last few days, is nothing but an AI technology that helps us create original content, such as text content, images, video, audio, or even software code. And all these Gen AI, models are dependent upon various machine learning algorithms and deep learning algorithms. The models work by identifying and encoding the patterns and relationships in the huge volumes of data and using the huge voluminous data to understand the user's natural language requests or questions and respond with the relevant new content. Now, Gen AI is not something new. It is not of 2024. It was there since 1960s when MIT computer scientist Joseph developed ELIZA, which was a text-based natural language processing application, the first chatbot. ELIZA used pattern matching scripts to respond to the typed natural language inputs with text responses. Then in 1999, NVIDIA shipped GeoForce. Now, it was the first graphical processing unit, which was originally developed for video games. Now, these GPUs, that is the graphical processing units, had become the de facto platform for developing AI models and for mining the cryptocurrencies. In 2004, Google autocomplete first appeared, which generated potential next words. That is, it was predicting the next words as users were typing their search terms. This relatively, modern example of GNAI was based on Markov chain, which is a mathematical model that we teach to even honor students in Delhi University under the probability theory paper. In 2013, the first variational autoencoders, VAEs, appeared, then followed by the first generative adversarial networks, that is the GANs, in 2014. In 2017, a team at the Google Brain, along with Ashish Vaswani and a group from the University of Toronto, published a paper documenting the principles of the transformer models. The paper was Attention is All You Need. It was widely acknowledged as enabling the most powerful foundation models and Gen AI tools. In 2019 and 20, OpenAI rolled out its generative pre-trained transformer, the GPT models GPT-2 and GPT-3. And finally, we have with us in 2022 the chat GPT introduced by OpenAI itself, that again is based on LLMs and is used to, generate new text. Now, what a deep fake is? Is anybody here having any idea about deepfake? You may type here or you may raise your hand to tell. Any idea about deepfake? Yes, Ms. Kalyani, could you please tell? Can we unmute Ms. Kalyani? Mr. Anirudh
We have
has told.
to Mr. to Ms. Kalyani.
Hmm.
We have already provided the mic permission. You can unmute yourself.
Hello.
Yeah.
Yes, sir.
Hello.
You're
Yeah. Good evening, ma'am. Actually, creating videos of people, those who are not there by using other people videos. That is a deep fake, which is able to do that.
Yeah. It can be a video, it can be an image also. It can even be, lip syncing some audio of a different person on a fake person. Yeah, thank you. So moving forward, deepfake is both a technology as well as the content that is created through this technology. So deepfakes often transform the existing source content where one person is swapped for another person. They can entirely create original content where someone is presented doing or saying something which they never said. This could be, seen in the, 2016 elections in USA when Donald Trump, was defeated. And it was all because there were many deep fake audios and videos circulated in the social media against him. So fakes are not just photoshopped videos or edited videos or images. They are in fact created using specialized algorithms which blend the existing with the images, the existing images or videos with the new videos and images. For example, the subtle facial features of people in the images are analyzed through the ML, algorithms. Deepfake basically uses two algorithms, a generator and a discriminator. The generator is the one that builds a training data set based on the desired output, creating the initial fake content, while discriminator analyzes how fake or how realistic the initial version of the content is. So generator is going to, generate the image while the discriminator will analyze that image and it will tell whether it is a real image or a fake image. So we can feed into the discriminator network the real and fake images, and it will give us the output as whether the image was real or not. Now, what are the various risks that are, there with the deepfakes? Deepfakes can be used to spread misinformation. They can violate consent. They can violate, privacy of people, security of people, not only of people, of organizations, of business organizations as well. Deepfakes can be used to create fake identities, to create malicious content, uh, to go against, somebody or go against some organization. Attackers use the technology to create false documents or fake their victim's voice, which enables them to create accounts or, purchase any products or transfer funds pretending to be that person. Now, what we should watch out for as vigilant users of technology, we have to be wary of the phone calls or the videos that appear to come from trusted colleagues or maybe family people or extended people, extended family asking you to uh, transfer funds or having any kind of unexpected demands. So what we must do is we must take note of the unusual or urgent requests to set up vendors to make purchases or process electronic fund transfers. Now, deepfakes are of high concern to the national governments of any nationality, of any country. Most often, the deepfakes are disseminated over the social media. Now, why so? Because it is estimated that there are 51.7 billion total social media users worldwide. And on an average, every user, uses 6.7 social networks each month. Using the social media, therefore, allows deepfake creators to spread that fake news or the malicious content in a wider audience. The media insight and research firm Fenimore Harper Communications found that between 8th December 23 and 8th January 24, over a period of 1 month, 100 deepfake video ads impersonating the former British PM Rishi Sunak were paid to be promoted on Meta's platform. These ads, whose funds were originated from 20 different countries, 23 different countries, may have reached over 4 lakh people. And it is not just celebrities or politicians who are affected by the rise in malicious deepfakes. Even the businesses are also among the latest victims. Now, how do deepfakes work? They are created in one of the two ways. They can either use the original video source of the target, where the person is made to say and do things they never did, or they can swap the person's face onto the video of another individual, also known as a face swap. Let us see a video that tells us in more detail how deepfake works. I hope the sound is audible of the video.
Let's play a game.
Yes, ma'am, audible.
Okay.
Let's play a game. I'm going to show you two videos. One is real, one is altered by AI. Can you spot the deep fake? Prime Minister Justin Trudeau recommended one of these books. Which one?
The book that I got excited about reading through. It's called This Can't Be Happening in MacDonald Hall. It's called How the Prime Minister Stole Freedom.
Yeah, it was the last one. The Prime Minister never said that. Okay, round two.
If you can see, I hope to finish this talk show one day.
Will the fake Morgan Freeman please stand up?
I am not Morgan Freeman, and what you see is not real.
How about these videos of Florida Governor Ron DeSantis? Did the presidential hopeful say this?
I'm the only one that could possibly compete with Donald Trump.
Or this?
I took some very bad advice. I did some very bad things.
The last one is fake, made to make you think that DeSantis was dropping out of the race. Look at the mouth, out of sync to the voice.
I never should have challenged President Trump.
One giveaway to a deepfake. For now. From Hollywood to Washington to Ottawa, deepfakes are confusing reality.
With AI, fraudsters can take 3-second recording of your voice. I've watched one of me on a couple of times. I said, when the hell did I say that?
Spend enough time scrolling, like me, you start questioning everything on your screen. How do I know that you're not a deepfake?
Ah, that's the right question, isn't it?
Hani Farid specializes in digital forensics at the University of California, Berkeley.
If you're trying to create a 10-second hot mic of the prime minister saying something inappropriate, that'll take me 2 minutes to do. And very little money and very little effort and very little skill.
Okay, so a video of a politician swearing or dancing won't set off national security alarms.
President Trump is a total and complete dip.
But as AI technology gets better and more believable, Farid worries about populations primed for manipulation.
What concerns me a great deal in this country in particular is how partisan we are. And when you have that kind of deep partisanship, that outright hatred of the other side, not just disagreement, the disinformation campaigns are much more effective because they will take hold because everybody's already there.
Here's something you might have seen before on your social media feed.
On artificial intelligence.
a deepfake of the Nationals' Ian Hannah Mansing that seems to be selling cryptocurrency.
More than $765
It's a scam. He never recorded that. It's made with AI. Okay, but what if during the next election you see multiple videos that look and sound like a journalist you trust telling you the date of the election has changed? Would you believe it? I think that's really scary when you think
And you
about
release that, 12 hours before election day, goes supernova viral. It doesn't matter if you correct the record 12 hours later. The damage has been done.
It's that threat to democracy that rattles this conservative MP.
Politicians have large digital footprints. You know, I have over a decade worth of speeches that are on the internet, writing, videos. It'd be very easy for somebody to put together a deepfake video of me.
Worried that Parliament isn't moving fast enough, Michelle Rempel-Garner helped set up a nonpartisan working group to tackle AI.
We haven't even dealt with telephone scams as a country, right? Like, we really haven't dealt with like beta version phone scams. And now here we are with very sophisticated technology that anybody can access and come up with very realistic videos, like indecipher or indistinguishable between the real thing and what's been produced. The question really is Canada ready to deal with this? Like, these are not conversations that are happening front and center in Parliament right now, and that is concerning.
Not far from Parliament, the worst case scenario is top of mind. Canada's cyber spies are already sounding the alarm about our first AI election. Carolyn Xavier is the chief of the Communication Security Establishment, or CSE, the sister agency to CSIS.
This is what we fear, is potentially that there could be a foreign interference so grave that then the electoral results are brought into question.
Simply put, is Canada ready for its deepfake election?
There's lots of work we continue to need to do with regards to education and, citizenship literacy. But do I think we, CSC, is ready? The Cyber Center, absolutely, I think we're ready, because this is what we train for. This is.
So right now I have a question, from the audience. What all you observed through this video? What is the impact of deepfake?
Hello, ma'am. It's Kalyani here.
Yeah. Anji, please tell. Yes, Kalyani ji. You have something to say?
Yes, ma'am. Actually, instead of helping, it is disturbing the system in most of cases. Not really it helping. Yes, definitely AI is helping, but this deepfake is disturbing more. Like having yes negative impacts on the social as well as personal life. If anyone is getting published socially, so his obviously personal life will impact.
Right. Maheshwari ji has told privacy is violated. And is there any positive impact of deepfake also, which we can think of? Because the video, as of now, talked about the negative impacts only. Like they are even fearing that there can be deepfake elections. Is there a positive impact of deepfake also? Can we think of any positive impact of deepfake? Anybody from the audience?
Ma'am, in entertainment industry, I think it can be used in a positive way.
Right. Entertainment, video games, in all these scenarios, it can have positive. Yeah, in creative fields like movies, definitely, right.
Oh, yes, ma'am. Those who are from the ancient or from previous ages to whom we have not yet seen. Okay, so we can listen them by using this deepfake technology. That how they worked, previous scientists.
Right.
Yes, we can listen them by using this technology.
Right. So moving on, how we can detect the deepfakes. Now, researchers are developing various technologies to detect deepfakes using the various algorithms of machine learning, deep learning, and media forensics. New standard bodies are creating some technical standards and policies to verify the source, of the content, the history of the content, the origin of the content. Even Adobe and Microsoft are working on the content creations to verify the authenticity of images and videos. Now, how Gen AI models, help in creating deepfakes or identifying deepfakes. There are three phases in which Gen AI operates. The training phase, which creates a foundation model that serves as the basis of the multiple Gen AI. Tuning to tailor the foundation model to the specific Gen AI application. Then generation, evaluation, and retuning to assess and analyze the application's output. Now, the milestone model architectures of Gen AI are the variational autoencoders that have driven the breakthroughs in image recognition, NLP, and anomaly detection. Then there are GANs, the generative adversarial networks, and the diffusion models that improved the accuracy of the previous applications and enabled some of the first AI solutions for the photorealistic image generation. Then there were transformers, the deep learning model architecture behind the most foundation models and Gen AI solutions that are there today. Now, some specific approaches for creating deepfakes are either you have the source video deepfakes or the audio deepfakes or lip syncing. Now, when we talk about the variational autoencoders, they work on the source video deepfakes. Now, what an autoencoder is? Now, it is a deep learning model having two connected neural networks, one that encodes a huge amount of unstructured data and another one that decodes those unstructured data or parameters to reconstruct the content. Technically, autoencoders can generate new content, but they are more useful for compressing the data for storage and decompressing for usage. Now, introduced in 2013, the variational autoencoders, also known as in short VAEs, they can encode data like autoencoder but decode multiple new variations. Now, by training a VAE for generating the variations towards a particular goal, it can zero in on more accurate and higher fidelity content over time. The early VAE applications included anomaly detection, for example, in medical image analysis and in natural language generation. So VAEs are the source, basis for the source video deepfakes. Then working from the source video, the neural network-based deepfake autoencoder will analyze the content in order to understand the attributes of the target, such as the facial expressions and the body language. It then imposes those features onto the original video. And this autoencoder then includes an encoder that encodes the relevant attributes and a decoder that imposes those attributes onto the target video. Now, the second model, the generative adversarial networks, they work on the audio deepfakes. Now, the GANs were introduced in 2014. Again, they are consisting of two neural networks, a deep learning architecture again that uses the two neural networks to generate images, a generator to generate the new content, and a discriminator that will evaluate the accuracy of the content, whether it is a real one or a fake one. These adversarial algorithms encourage the model to generate increasingly high quality outputs. The generator adds noise to the image representation, while the discriminator will identify if the image is real or not. Now, GANs are used for image generation. They are also used for image and video generation, but can generate high quality, realistic content. They have been successful at tasks such as style transfer, like for altering the style of an image, say a photo to a pencil sketch. Similarly, they are also successful at data augmentation, creating new synthetic data to increase the size and diversity of the training data set. So for the auto deepfakes, again, clones the audio of a person's voice, creates the model based on the vocal patterns, and uses the AI model to make the voice say anything which the creator, that is the deepfake creator, wants to. Now, video game developers commonly use this technique. Then we also have lip syncing, which is another common technique used in deepfakes. Here, the deepfake is going to map the voice to the video, making it seem as though the person in the video is speaking those words in the recording. If the audio itself is a deepfake, then the video will add an extra layer of deception. So, which means audio itself is deepfake and the video is also adding the deepfake content to it. This technique is supported by the recurrent neural networks. Now we have diffusion models. Again, they have been created on top of GANs only. They work by first adding noise to the training data until it is random and unrecognizable, and then training the algorithm to iteratively diffuse the noise to reveal a desired output. The DALL-E, which was the OpenAI's image generation tool, is driven by the diffusion model. Then there are transformers. They were first documented in that Ashish Vaswani paper in 2017. These models are at the core of most of today's headline making, Gen AI tools like ChatGPT, Copilot, BERT, Bard, and Midjourney. Here, I would like to stop and ask anyone if you have used Copilot in any of your projects while teaching students. Anyone? Nobody has? Dr. Nisha is telling you. Can you tell how have you used Copilot? I would like to know. Dr. Mukta and Dr. Nisha. Please unmute yourself and tell us.
Ma'am, Dr. Nisha this side.
Hanji.
Ma'am, I have used Copilot like we use Chat GPT. So nothing sort of into such any specific function like Gemini, Chat GPT, and Copilot we
Have you
use.
used it
I
for
have
coding? Have you used it for coding?
no, ma'am. Being from the electronics background, I have not used it for coding.
Okay. Thank you.
But I have
Dr.
used this platform.
Hanji. Hanji, could you please repeat? I couldn't get what you said.
I have used it, but not for this coding purpose.
Okay. Dr. Mukta, how have you used it? Has anyone here used Copilot for coding purpose? Nobody. So then I should show you how you can use it. Let me just stop my slide over here. Because Copilot can be used in VS Code. And now VS Code is an editor that can, help you to code in any programming languages, whether you want to program in Python or C++ or C language. And basically it is an aid in, helping teach students programming, but we will not like the students themselves to use it directly, but it's basically the Copilot version in the GitHub has provided an option to the academicians. If you register yourself at GitHub with your organizational email ID, it will provide you to download an extension of the Copilot to use it for your programming purposes. Now here I'm trying to create a Python program in which I want to maybe extract odd numbers from a given string or a given input. So what I can do is I can simply, write a comment over here First, I would save this file as a Python file. Suppose I am saving it with test p1 name. And now I am writing a comment. Here, comments are written using triple quotes, in Python. So I'm saying that I want to write a function. See, it is giving me the prompt automatically. So I can just press tab if I want to do the same thing. I have pressed tab. So write a function that takes a list of integers and returns the sum of all integers in the list. Now what I'll do, I'll just get out of this comment and I'll try to just define a function. For defining a function, I have to use def keyword. So now see, it is automatically giving me the entire function. It is giving me the entire function to take the input of the list of integers, from the user, and then returning the sum of the integers in the list. And it is also giving me the prompt to give a, input, which is a default input it is giving me. And it is also telling me the sum, what the sum should be. So if I run this code, I have to print also, right? So I haven't printed anything. So what I'll do is I'll save the, output in a variable. Maybe res is the variable that I'm using over here. And then I will print this res result variable. Let me clear this output window first. So what you can see is with the help of Copilot, I am able to write in comment in simple English-like language, English language only, what I want to do. And it will automatically generate me the code for it. So it has given me the code. It has given me a function. It has automatically created the function name as sum of list. And then it is returning using the predefined function sum that will work on this list. And it is also giving me a default kind of input that I can use on this function and which will return the result also and print that result out for me. It is exiting and it is running, though it is not telling me the code yet. Let me see. It is not giving, but it has generated this code. And you can write any code, any complex code with the help of this Copilot. So in case you want to create, new problems also, new programming problems, you can create, as an academician, as a, as a professor of programming language, you can use this tool very efficiently to create new programming problems for the students to create, good even question papers. But it should be used, as a tool to aid you. But it should not be given directly for the students, to explore them. Otherwise, they may, stop the students from using their own logic. So that is upon us, the users, how we are using the technology, the AI for enabling us, in maybe in supporting our education or, just stop using our brain. It all depends upon us. So it is one of the, applications of generative AI tools only that we can use. So has anybody used it? If not, you can just go on GitHub and register yourself over there, over your institutional, using your institutional email ID, and you will be able to use. Okay. Let's move forward. So I was talking about these, transformers such as Copilot only and GPT. Obviously, everybody has used ChatGPT. Transformers use this concept called attention, which is used for determining and focusing on what's most important about data within a sequence in order to process the entire sequence. In addition to enabling faster training, transformers are used for natural language processing, for natural language understanding, and can be used for generating longer sequences of data. For example, not just the answers to questions, but the poems, articles, or even the papers with greater accuracy can be created. The transformer models can be trained or tuned to use the various tools such as the spreadsheet tool, the HTML, or any drawing program to output the content in a particular format. Now let us see this particular video, which tells how we can detect a deepfake.
Hey everybody, it's Kalen from Kite, the AI-powered coding assistant, and today we're going to explore the topic of deepfakes and examine a neural network designed to identify them called Mesonet. The concept of deepfake refers to images, audio, or video that are fakes. That is, they depict events that never occurred, but unlike methods of manipulating media in the past, like Photoshop, these deepfakes are created by deep neural networks to be nearly indistinguishable from their real counterparts. Check out this video of President Obama addressing the nation, for example.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time.
Did anything sound strange? That's because it wasn't Obama speaking, it was Jordan Peele. The advances in the field of deepfakes are equal parts impressive and alarming. On the upside, the fidelity with which we can alter media will certainly lead to some world-class memes. But in the wrong hands, this technology can be used to spread misinformation and undermine public trust, almost like a sci-fi type of identity theft where you can get anyone to say anything and its opposite. This means that as we get better at generating deepfakes, we must also get better at identifying them. Mesonet is a convolutional neural network designed for exactly this purpose. In today's video, we'll use Mesonet to make predictions on image data. We'll examine 4 sets of images: correctly identified deepfakes, correctly identified reels, misidentified deepfakes, and misidentified reels. And we'll see whether the human eye can pick up on any insights into the world of deepfakes. Let's begin with a brief discussion of Mesonet. And by the way, you can find a link to the author's white paper in the description below. In the paper, the researchers explained that they had developed 2 different models to identify deepfakes, both of which were trained and evaluated on 2 different datasets. We will be using the Meso4 model trained on the deepfake dataset. Now let's begin by exploring how deepfakes are generated and how this dataset was assembled, and then we'll proceed to the model. Deepfakes can be generated by using autoencoders. At the highest level, autoencoders work like this. When the data are processed, such as image data, data get compressed by an encoder. The purpose of this compression is to suppress the effect of noise in the data and to reduce computational complexity. Conversely, the original image can be restored, at least approximately, by passing the compressed version of the image through a decoder. Now suppose we want to create a deepfake that blends Van Gogh's Starry Night and Da Vinci's Mona Lisa. To do so, when we train the autoencoders for different datasets, we allow the encoders to share weights while keeping their decoders separate. That way, an image of the Mona Lisa can be compressed according to a general logic, taking into account things like the illumination, position, and the expression of her face. But when it gets restored, this will be done according to the logic specific to the Starry Night, which has the effect of overlaying Van Gogh's distinctive style onto Da Vinci's masterpiece. Although this is how deepfakes are often generated, the authors note that their deepfake dataset was created differently. Rather than generating deepfakes from scratch, which they explain would limit the amount and diversity of the fake data that they could then feed Mesonet, they chose to extract face images from existing deepfake videos. They used about 175 existing videos pulled from popular deepfake platforms, and that created their deepfake dataset. They explain that they extracted the specific frames that contain faces from the deepfake videos. They also note that they followed a similar process for extracting the real image data from real video sources like TV shows and movies. And finally, they explain how they stratified their data so that the various angles of the faces and levels of resolution were distributed evenly across the real and deepfake datasets. Since machine learning is all about finding patterns in data, it's actually extremely important to understand the nature of the data and how it's collected, because you're ultimately going to feed that through a model to understand it. As you'll see later, with this understanding of the data, we reveal some important insights, but stick around for that. Let's first explore the model. MESO4 is a convolutional neural network with 4 convolutional blocks followed by 1 fully connected hidden layer. As we reproduce the model, we'll explain what each of these means, and you can find a link to the Mesonet authors repository in the description as well below. I want to take a minute to talk about Kite, which is an AI-powered coding assistant that'll help you code faster and smarter. Whether you're new to Python or already a pro, you should try out Kite as your autocomplete to reduce your keystrokes and save time programming. Kite is a free plugin for your code editor that uses machine learning to save you keystrokes while you're programming. So if you're using Atom, VS Code, Spider, PyCharm, Sublime, or Vim, Kite will seamlessly integrate into your coding workflow. Kite can complete entire lines of code, and it has a feature called intelligent snippets that will help you fill in arguments and method calls with variables defined earlier in your script. The window on the right side of my screen here is also a Kite feature called the Kite Copilot. It automatically shows you relevant Python documentation while you type based on your cursor location. This saves you time from having to Google search for docs. The best part of Kite is that it's free and you can download it from the link in the description below. Let's begin with our imports. And then let's create a dictionary called image dimensions to store our image dimensions, which are the height and width of the image in pixels and the number of color channels. We set the height and the width to 256, and since we're using color images, we want to set the channels to 3. Then we create a classifier class just as the authors had done, which makes for very neat code by prescribing just the essential methods for the network in simple terms. We will be using the methods to load weights and to make predictions. And next, let's create a MESO4 class. The MESO4 class takes just one argument, and that's the classifier class we just created. We set the gradient descent optimizer, and we set its learning rate in the constructor, and we set the parameters to compile the model. Now it's time to create the network architecture. We create a method called initModel. First, we create our input layer and assign it to the variable x. For the input layer, we just need to pass the 3 dimensions of our image data. Then, we create our 4 convolutional blocks. Convolutional blocks always include a convolutional layer and a max pooling layer. And in Mesonet, these blocks also include a batch normalization layer. The convolutional layer, represented by conv2d, is the trickiest part. Here we set the size and the number of filters we will use in convolution. Check out this illustration. Here's how it works. Each filter represents a distinct image feature, for example, a horizontal line. During convolution, this filter is passed over an image to assess the degree to which specific regions of that image correspond with the filter. If you're a math whiz, this is done by calculating the dot product of the filter with each filter-sized region of the image for each of the color channels. For the rest of us, the important thing to know is that the filter identifies the existence and location of specific image features, like horizontal or vertical lines. After the convolutional layer comes the batch normalization layer. Batch normalization is a novel technique for improving the speed, performance, and stability of neural networks. It works by normalizing the inputs to each layer of the network, which reduces the interdependence between the parameters for a given layer and the input distribution of the next layer. This interdependence is called internal covariate shift, and it has a destabilizing effect on the learning process. For more about batch normalization, check out the link in the description below. The last layer of our convolutional blocks is the pooling layer. It is in the pooling layer that we significantly reduce the dimensionality of our data, which greatly speeds up computation. Mesonet uses max pooling for this layer, which means we reduce a region of pixel values to that region's maximum value. It may seem like we're throwing away too much data in this pooling layer, but remember, during convolution, our model was able to locate important image features, which means we can focus on just the parts that matter most. Think about your own visual field right now. odds are you're focusing on a very small subset of the available data, just like MesoNet. With successive blocks in the convolutional base, CNNs proceed to higher order feature representations, from lines to corners to shapes to faces. MesoNet has 4 blocks in its convolutional base, followed by a fully connected hidden layer, and then the output layer for the prediction. Now that we've got the network architecture established, we need to instantiate the model and load the weights. We download the weights from the MesoNet GitHub repo, and then save the file meso4df in a folder called weights. We load the weights using the load method of our classifier by specifying the file path. MesoNet is now ready to make predictions on image data, so next up, we start preparing our image data. We download the deepfake validation dataset from the MesoNet GitHub repo. Again, that's linked in the description below. We structure our real and deepfake image data in separate folders underneath a folder we call data. This is important for the flow from directory method, which infers classes from the file structure. The pixel values in our image data exist in the range between 0 and 255. Large integer coefficients like this complicate gradient descent when using typical learning rates. So, the next step is to scale our data by a factor of 1 divided by 255. That way, the pixel values fall into the range from 0 to 1. We instantiate our image data generator that rescales our images. Then we pass in our data by specifying the directory path to our data folder. We set the batch size to 1, so we process images individually, and then we set the class mode to binary for our binary classification task of predicting images as real or deepfake. Now, let's check our class indices. Flow from directory should have inferred the names of our classes from the names of the subfolders within the data folder, and there should be just 2 classes, where our deepfakes are represented by 0 and our reals by 1. There are 2 problems that might arise. First, if your classes are reversed such that your deepfakes are represented by 1 and the reals by 0, you'll have to flip MesoNet predictions by subtracting these values from 1. The second issue relates to having more than just 2 classes. As we discussed, flow from directory uses file structure to process data, and is therefore sensitive to the structure. Many IDEs, including Jupyter Labs, which we're using today, will conduct periodic autosaves and store this data in hidden folders called directory that holds our data and removing the hidden file. Or we can do this directly from a Jupyter cell by using a magic command. We just type the exclamation mark to invoke the command line interface and then issue our command to remove this file. After this, let's return the image data generator and recheck our class indices to ensure we successfully removed this autosave folder. Great, things are looking good now, and we're ready to pass in an image through MesoNet. The generator.next method returns 2 items, the pixel data of a given image and the actual label for it, whether it's real or a deepfake. So let's set variables x and y equal to generator.next. Let's write 3 print statements to evaluate the prediction. For the first, let's show MesoNet's predicted output for the image rounded to 4 digits. For the second, let's show the actual label. And for the third, let's see whether MesoNet's prediction is accurate. That is, whether the actual label corresponds with MesoNet's predicted output after rounding to 0 or 1. We can also see the image in question by using the imshow function from the matplotlib.pyplot package. Our x data currently has an extra dimension for its position in the batch, and this needs to be removed before imshow can properly render the image. We can do this by using the numpy function squeeze, passing numpy.squeezex as the argument for plot imshow. Now we can see how MesoNet performed on a particular image. When predicted outputs are nearly 0 or 1, this corresponds with a high degree of confidence in the prediction. But when the predicted output approaches 0.5, the confidence in the model prediction approaches a random guess. So let's run this a few more times, and let's see if we see any patterns. Let's organize our predictions into 4 categories: correctly predicted deepfakes, correctly predicted reals, misclassified deepfakes, and misclassified reals. And we create lists to keep track of which images fall into each category. Then we write a for loop to iterate through our data set and sort each observation into one of these 4 categories. We create 2 lists for each category, one to store the image data and the other to store the corresponding prediction value. Now let's create our plotter function, which we'll use to show random batches of images in each category. Plotter takes 2 arguments, a list of image data and the list of corresponding predictions. We use an F string for the X label so we can show Masonet's predicted output for the image in question. Let's check out a collection of correctly identified real images. We pass correct real and correct real pred into our plotter function. Checking out these images, things look pretty good. You might see some characters from TV or movies that you recognize here. Look at the predicted output for the images. The closer these values are to 1, the more confidence Masonet has that the image is real. Notice that most of these outputs vary between a range pretty close to 1. Okay, for contrast, let's look at real images that were misclassified as deepfakes. Let's again use our plotter function, but this time we pass it misclassified real and misclassified real pred. Although these are all representing errors, it is reassuring to note that the model's confidence for these predictions tends to be closer to 0.5, and that's to say that it's less confident in these predictions that turned out to be wrong. So it's pretty much a guess, and I guess that's okay. Now let's check our correctly identified deepfakes. Whoa. Okay, that's an odd pattern in our data there. And let's also check the deepfakes misclassified as real. We now return to Masonet's method of collecting deepfake data. You may recall that they acquired deepfake image data from popular deepfake video platforms that are online. Well, according to the September 2019 report called The State of Deepfakes, conducted by Deep Trace Labs, 96% of deepfake media is pornographic. Deepfake pornography is among the worst abuses in the world of deepfakes, and besides being a significant social issue, this also complicates the technical side of our deepfake classifier. Here is why. Masonet was trained on real data acquired from TV and movies, sources that offer a great variety of facial expressions and settings. However, the deepfake data that the authors acquired was from popular deepfake platforms on the internet, sources that are overwhelmingly dominated by pornographic content. Therefore, it's expected that the model took advantage of a data artifact, the statistical reality that deepfakes tend to be pornographic and reals tend to be non-pornographic, and used it as a heuristic for its predictions. The authors explain that the models make predictions under real conditions of diffusion on the internet, which explains. Hey everybody, it's Kalen from Kite, the AI-powered coding assistant, and today we're going to explore the topic of deepfakes.
So, in this video, it was shown through the Python language how we can use the various, built-in functions that are available in Python to apply the machine learning and deep learning algorithms, the deep learning models such as the convolution model, which is being here, the Mesonet network is the convolution network only, which is a deep learning network or deep learning model, which is used to identify deepfakes. So if you know Python and you want to, explore more in Python, especially you can start with implementing the ML algorithms, the deep learning algorithms gradually can be, then implemented. So, does anyone have any questions so far? We should have, we can discuss if you have anything in mind. And probably we can have, maybe some other time a presentation or a hands-on session on creating, and implementing such ML and DL models for identifying deepfakes.
Ma'am, hello.
Anji, yeah.
Being from the electronics background, whatever you have discussed today, can it be relevant something to hardware or VLSI, like semiconductor in the field nowadays? So can we relate these things to semiconductors or VLSI somewhere? Any model
Because I think from being in the electronic side, maybe you might be using embedded systems also, if I'm not wrong.
the FPGA system hardware board?
Because internally one has to code it, even if we have a device, made that you are saying, for the hardware, a hardware device, if you want to make it internally, you have to implement some algorithm. Yeah, like Ms. Kalyani has told, IoT can be used, Internet of Things. The sensor networks can be used, and internally you can implement, these ML and DL models.
We can proceed with that.
Ma'am,
Maybe I
can
have missed
we?
that part of.
Yes.
Maybe I have missed that part of Ms. Kalyani, ma'am. You are saying that IoT part. So can you please
She has written in the
repeat that
chat
thing?
box. She has written in the chat box that we can use IoT. IoT is that we all know it is Internet of Things. So it makes use of definitely the devices, the networks also. It uses various wireless and wired networks also, which can be then you can internally implement, convolution networks so that you can have the effect of an AI device, because that is the next in thing, the robotics, that the robot that you create, that is an AI device only. It's a hardware device. Internally, you have to implement some logic, some algorithm so that it works, because we have to, feed some information into that device so that it can predict like a human. Ms. Charu has said.
Internally, these algorithms have to be deployed where in machine.
Of course. Yeah, because
Like you are saying, internally these
because
algorithms.
these algorithms are actually, you will need a software to implement them. You will need some software code to implement them.
Ma'am, can the deepfakes be created using other technologies also, other than CNN and GNN, like the using 3D modeling or computer vision, etc.?
You can create them, definitely. There are more models which can be used.
Can you elaborate it on?
Like we have talked about
3D
GAN.
modeling?
You are talking about CAD CAM. Are you talking about CAD CAM?
Yeah, 3D modeling related to the computer graphics or computer vision.
I think Ms. Kalyani is answering here that by using IoT, you can program on the machine and then connect to the sensors or hardware. Because 3D model, what will it do? It will help you in, creating a design. The design will be created through models, but obviously you will need some logic to, implement those machine learning capabilities. Finally, that will be required, Dr. Pallavi.
This deepfake is a plus part we can consider in technology, or is a negative part?
Deepfake.
Yes, ma'am.
See, that is what I'm saying. No? Deepfake has two aspects. If you are using it, like for example, if you are using for 3D modeling, you are going to use in movies, maybe in animation or in entertainment industry, that will have a positive impact because it is giving you entertainment. But when you are using, when somebody, the creator of the deepfake is using to, spread misinformation or to spread malicious content, then obviously it will have a negative impact.
What are the potential future applications of deepfake technology?
That is what, like if you are, getting into this, if you are learning about this technology, you will also be able to create the solutions for it, how not to spread the fake information. Again, we have some input from Ms. Kalyani. She's saying that technology is doing the best in invention, but people are misusing it. Absolutely correct. So we have
like
two engaging
AR, VR also. AR,
people.
VR also.
Yeah, why not? We have two engaging participants with us, Dr. Nisha and Dr. and Ms. Kalyani, along with, of course, Pallavi Bhatt ma'am. Can we have input from other, people in the audience also?
Any other queries from participants?
I would like to, those who have a little bit of, programming background to definitely use Copilot for, creating new projects for the students or new assignments for the students.
Ma'am, like in the electronics, VLSI things, the hardware description languages are there, like BHD and Verilog. So, like you were telling, Copilot for Python projects. So, similarly, we can bring projects in any language.
It can be in C, it can be in C++, it can be in Java, any programming language.
Have account and official account, we can create.
Yes, you just go to GitHub and register yourself with your official, institutional email ID. Only then it will allow you. And you have to register as a
We have to
faculty,
go
not
to
as a
Copilot
student.
and we have to log in. Okay, we have to go to Copilot. We have to make an account and then registering as a faculty. Then we can
Yes,
do the
yes.
same steps like you were telling.
And like on VS Code, just like I told you, let me show you once again. So
That
here,
thing you
what you
were
have to do is
telling
you
that
have to
three inverted commas.
you have to download the
Telling that three inverted commas.
Ma'am, there is another question also. How
Hmm.
deepfake influence the medical domain?
It can be, used for analyzing the correct result from, for example, the MRI scans or the CAT scans, whether they are, correctly generated or not. In that, the deepfake technology can help. Yes, Ms. Kalyani, you want to answer? Please unmute yourself. Yeah.
Yes. Thank you for this opportunity, ma'am. So actually, I am a PG scholar. That's why I'm trying to enhance my knowledge. Okay, so I'm reading a lot in
What's
various
your area? What's your area of research?
artificial intelligence and machine learning.
That's great.
Yes.
Yeah.
So I already had a worked on a medical field. Okay. So the question is how deepfake influence the medical domain. Okay. So everyone knows in the medical domain we need a lots of images. Okay, to train the model. So by using this generative AI or deepfake technology, that generative AI also comes in this area itself. So by using that technology, we can generate a lot of images, which can help our model to train precisely. We cannot get particular images from any particular hospital, but whatever we already have images, by using that we can generate a lot, and we can train our system. That is the main application. Until I have heard or I have read.
Okay. Thank you.
Yes, thank you, ma'am.
Ma'am, there is another question in the chat box. Are you able to read?
From Mr. Anirudh, I believe.
Yes.
It was pretty clear disadvantages outnumber the advantages that counter on local host, I believe. So why the team available on the public domain? Public domain, actually, through social media, anyone can popularize. Why? Because they can create any content. The technology is available for everyone to use. Any programmer, even, can, sometime have in his mind and, create something negative also. But there lies the technology which can, can detect, and maybe that person can be, arrested for in case that person is harming somebody's identity. Gen AI helps to create synthetic data. Yeah, it helps. Synthetic data is only that data which is uh, the data which is fake. Any specific tool for deep fake detection? They are not the tools or the applications only. Like for example, just now in the video we showed, we saw Mesonet can be used for deep fake detection, which we have implemented on Python, which can easily be implementing using any Python framework, whether you use a Google Collaborator or maybe Python Idle or maybe Anaconda. Yeah, there are machine learning algorithm. This is the deep learning algorithm of convolution network only. It is available in Python. You can directly use it. And if you want, maybe I can share the resources through the organizers. So those who are interested can look into this code also. I can share that. To balance the data set, we can go for synthetic data, but still it is called deepfake data. Synthetic data, if it is against, totally against the real information, then it will be deepfake only. Whether if you are generating something like real and using it for the correct purposes, not for the malicious purposes, then it will have a positive impact. Any other queries? I'm really happy and glad to have a wonderful, engaging audience. And I hope the presentation was not boring and we learned something. All of you learned something new from it. Any other queries? Thank you, Mr. Sobru.
Any queries? Please ask if you have any questions.
Thank you, Kalyani ji. Sure, I'll share the PPT with the organizers as well as the videos. Thank you, Kripaji. And I would really like to thank the organizers, especially Pallavi ma'am, for inviting me to this FDP.
Thank you, ma'am, for such a informative session. I'm handing over to the Mansi ma'am.
Okay.
Thank you so much, ma'am, for that insightful and engaging session. We deeply appreciate the knowledge you have shared with us today. As we come to the end of today's session, I would like to take this opportunity to express my heartfelt thanks to all those who made this session a great success. First and foremost, I would like to extend a sincere thank you to our esteemed speakers, Dr. Ratan K. Datta and Dr. Ashima Hasti. A big thank you also goes out to all the participants. As we close today's session, I would like to request all participants to kindly fill out the feedback form that has been shared with you in the group. Lastly, I would like to remind you to join us tomorrow for another insightful session. Once again, thank you all for being a part of today's session. Have a great day ahead, and we will meet tomorrow. Thank you.